Hey, how's it going, everybody? My name is Jonathan Kay, and I'm going to be talking about my study, which was evaluating the safety performance of unsignalized median U-turn intersections. Fresh off my second dose of the vaccine, like literally an hour ago. So hopefully, I make it through before the side effects hit, but I'm sure I'll be fine. Um, Jumping right in. So what am I talking about with median U-turns? This is a design approach where we're replacing the direct left turn movement at an intersection with a indirect left that's typically accommodated via directional U-turn crossovers. And we've been using this approach in Michigan for several decades, going back all the way to the 1960s. We've continued to expand use of it here, as well as a few other states, but they're not nearly as ubiquitous in other states as they are here. We also use them along rural and suburban highways, which is going to be the focus of this study, as well as frontage roads for urban freeways. Now, I'm going to be focused on the safety benefits of median U-turns, but oftentimes we install these for operational reasons. So because we can eliminate the left turn signal phases, we can reduce delays and improve progression. So like I said, a lot of times we install them for operational reasons, but we also can derive some safety benefits. So quick example of what a unsignalized MUT looks like. We just note here, and this would be in contrast to the, a signalized MUT where we've got the closed median here. So we do force the minor approach drivers to make that indirect movement. So you turn right, use crossover, and either drive on straight through to complete your left turn or make another right move turn to complete your through movement. There's no interior crossovers on this guy. We just have the two exterior crossovers here. I think that's about it. Yeah, just note also that when I say unsignalized, what I'm referring to is the major approaches don't stop. They have no they're uncontrolled, and the minor approaches are controlled with a stop sign. So without diving too much into the prior lit, just theoretically, we would expect better safety performance with the MUTs because we're reducing conflict points. So if you look at the figure on the left here, we've got a total of 32 conflict points at a conventional intersection. And on the right, the standard MUT design, we dropped that all the way down to 16, primarily by getting rid of these crossing or reducing the crossing related conflict points. Now, note, like I just showed, typically we're closing the median with the unsignalized MUT. So these four red crossing conflict points would also be dropped out. So just keep that in mind. In terms of the objective of the study here, the idea is to develop CMFs for two types of unsignalized conversions. So the top side here, where is the top scenario is a two-lane, two-way roadway here in the top left. And let's say we're getting to a scenario where maybe the traffic lines are getting too high and we want to go to a four-lane boulevard. These would typically be implemented like along the whole corridor, but you see on the right here, we've gone to that four-lane boulevard with the MUT. So as I mentioned, this would be sort of more done as a whole corridor as opposed to just like a one-off. On the bottom side, the more common scenario here is, we already have a undivided four-lane undivided highway, but we have that median opening here that allows direct lefts from all the approaches, and we're simply closing that up. So on the right here, you see it's closed, and make sure you have your crossovers, and now we use those indirect lefts to complete left turn movements. So the first step in the study is just to identify where these are. Believe it or not, MDOT does not necessarily have an inventory of these offhand. So I developed an algorithm to identify both reference sites, so the conventional sites, as well as the MUT sites, using the Michigan Geographic Framework. And that is just an inventory of all public roads in the state. On top of identifying where they were, we also need to identify when or if they were converted during the study period, which was 2004 to 2019. There are cases where I don't have pre-conversion data because, as I mentioned, they've been in place for several decades in some instances. So we do have some examples with before and after, but just recognize there are also some sites that we only have post-conversion data. And I'll cover that when we get to the analytical methods. Just in terms of where these are located, generally they're located along the state trunk line, arterials, and suburban and rural areas. So you can see most of them are kind of in the area where we're going from an urban area out into, you know, getting more rural. So it's sort of a mix of rural and suburban land uses where you often see these. Now, in terms of collecting the crash data, I drew these windows by hand in ArcGIS, and they remain the same for each year of the study. So in terms of how they were set up, along the major approach, we went 1,070 feet in both directions, and that was selected to be as large as the farthest away crossover in the study. So you see in this case, we go a little bit beyond the first crossover there. And then on the minor approaches, it go 300 feet away from the center of the intersection. So that you end up with this window that looks like the thing I've got drawn here. Study crashes are in green. Those are the ones that ultimately get associated with each intersection, and the non-study crashes are in red. Also note that I removed animal crashes from the sample. So we don't necessarily want to associate those with the treatment. In terms of sample sizes, and this is where things get a little tricky, as I mentioned, because I've got some sites that have pre and post conversion data and some that are post conversion only. So on the undivided side, that sort of that first scenario I talked about, I've got 27 reference group sites. So that they were never converted. They still remain two-lane, two-way conventional intersections. In terms of the MUT sites, I only had 3, and this is going to be tricky later on when we get to the analytical side of things. So just remember that 3 for now. On the divided side, we've got 29 reference group sites and 24 MUT sites with both before and after data. So much better sample size here, which is going to be helpful when we get to doing the analysis. And then, as I mentioned, we've got 12 sites with post-conversion only data. So in terms of the approach to the study here, I developed a series of negative binomial regression models with the site-specific random effect. And that's going to be pretty important because we do have repeated measures where one of these sites is going to show up several times in the database. And we do have a few cases where certain sites didn't perform super well after conversion. So that site-specific random effect helps control or accommodate for that fact that we have those repeated measures. Developed distinct models for fatal injury and total crashes. So just a quick example of one on the right here. Don't want to get too bogged down into showing you a bunch of model results, but this is a model that I developed for the MUT site, so the after period data only, and total crashes. So each of them are kind of set up like this, where you have the intercept, you have the major approach volume in terms of the natural log of vehicles per day, same thing for the minor approach, and then our over dispersion parameter. And using these models, I developed CMFs for both using both the EB method and cross-sectional approaches, and I'll get into how those vary coming up here. Just to visualize quickly before we get into the results, this is for undivided conversions, and this would be using the cross-sectional approach. So fatal and injury crashes on the left, total crashes on the right, and you see the pre-conversion SPF here in green and post in red. So you can see, at least in terms of fatal and injury crashes, much better performance after conversion for the undivided scenario in terms of fatal and injury crashes. Total crashes, it did look like it performed a little bit better, but we're going to see that this is going to end up not being statistically significant. But you can definitely see fatal and injury crashes are dropping down after conversion. In terms of the divided conversions, pretty similar results here, where again you see post-conversion fatal and injury crashes are dropping down quite a bit, and literally almost no change in terms of total crashes, for the divided conversion. So after running all the math, these are all the crash modification factors I considered as a part of the study. So jumping into the undivided first, and again, I've got the EB method approach, which again has a pretty small sample size, at least for the undivided conversions, cross-sectional approach, and repeat that same thing for fatal and injury and total crashes. So on the fatal and injury side for undivided, you see the EB method and cross-sectional are pretty close. Now, in the end, because we only had 3 sites, I wouldn't put a whole lot of weight into the 0.385 CMF there. Really want to focus on this cross-sectional one, just again because of sample sizes. This was statistically significant, but what's the practical significance of 3 sites is not very high. So in the end, I'm going to recommend this 0.438 CMF for the undivided conversions, and it's generally in agreement with the EB method approach, but just a much bigger sample size. On the total crash side, the numbers in red here, the cross-sectional approach was not statistically significant. Just like we saw in the graphs, the crashes did go down a little bit, but not a statistically significant finding there. And the EB method approach actually was statistically significant, but again, 3 sites. So I wouldn't feel comfortable recommending a CMF with just 3 sites. On the divided side, fairly similar. So in this case, we do have enough data for the EB method. If you recall, I had 24 sites. So, and we're going to end up recommending this 0.686 CMF. The cross-sectional was a little bit more aggressive. At least they're sort of in general agreement, but going to stick with this a little bit more conservative CMF, and that was developed using the EB method, which is sort of the gold standard compared to the cross-sectional. But the cross-sectional at least confirms at least the general direction was correct. Now, in terms of total crashes, just like we saw in the graph, on the prior slide there, not much change before or after, and neither approach was statistically significant. So in the end, the CMFs that we're going to recommend for unsignalized MUT conversions, nothing for total crashes. The data doesn't support it. And that sort of makes sense intuitively. We are eliminating those crossing related conflict points. So we are addressing some, the potentially severe crash types, and that's what we're seeing with the fatal and injury crash CMFs here. So 0.438 for the undivided conversion and 0.686 for the divided conversion. But we're not significantly impacting the total crashes. So in the end, that's what I've got. And thanks for